Hello, grade 11s. I forgot to turn on my mic. So I'm sorry, I will start again. So what we did yesterday was we started with the parabolas of grade 10 and there was no x term. And we had an equation y equals ax squared plus q. Now that was because the y-intercept and the turning point was the same point, and it was a point on the y-axis. Okay, now what we're going to do in grade 11 is we're going to move that parabola, we're going to shift it to the right or to the left. So the parabola is not symmetrical in the y-axis anymore. So if we add this bx term, that means that your parabola shifted to the left or the right. Okay. Now, the c value will give me the y-intercept. And you can see why, because for y-intercept, I make x0. If I make this x0 and I make this x0, this term falls away and this term falls away. And then my c is also my y-intercept. Okay. A still gives me the shape. So if A is positive, it's still a smiley parabola. If A is negative, it's still a sad parabola. So I said already, this B tells me that the parabola, that there was a shift to the left or to the right. So it influences my turning point. Now I will show you now how that works. And then the X and the Y, you know by now, this X and that X is the same X together with that Y is what? The coordinates of any point on the parabola. Okay. So now, if I can just show you, now my parabola, if it moves to the right, if it moves to the left, doesn't matter if it's smiley or sad. Can you see that the turning point is now not on the y-axis anymore? So now my turning point's x value, the x value of the turning point, y value of turning point, the x value of the turning point is now the new symmetry axis. So the new symmetry axis is x equals the x value of the turning point. Whether I have a sad or a smiley parabola, there's my new turning point, x of the turning point, y of the turning point. The x coordinate, a line through the x coordinate, give me the symmetry axis. Okay, now we said there's a new turning point, and the new turning point is not on the y-axis because it shifted left or right. Now, how can I get the new turning point? I use this formula. And please, people, this formula is not on any formula sheet. You must go and study this. X equals minus b divided by 2a. Now, where do I get a and b from? From my equation. So can you see the b together with the a help me to find the new turning point. And the formula is x equals minus b over 2a to get the x value of the turning point, and then to get the y value of the turning point, I just substitute this x into my equation. Okay, that's the one equation that you have for the parabola. Now let's practice that first. I ask you to draw the graph of fx equals x squared minus 2x minus 8. Show all the critical points. Now what's critical points? Critical points are the intercepts with the axis as well as the turning point. So you must show the intercepts with the axis as well as the turning point on your graph. Otherwise, you're going to lose marks. And then I also ask the equation of the symmetry axis as well as the domain and the range. Okay. Now, first of all, you know that fx just means y. It's just another way of writing y. Now, why do we do that sometimes? Especially if we have more than one graph on a set of axes. If we call the one f and the other one y, then we don't have to write the whole equation on the graph. We can just write f or g. Okay, but fx means y. So, okay, sorry. It's Ermelo's load shedding. So we lost connection because of that. I hope that you can hear me again. Okay, so fx just means y. So I have nothing strange or different. It's just the equation y equals x squared minus 2x minus 8. Now, can you remember from yesterday? We have our steps. So the first thing is the shape. And because, can you see there's a 1 in front of the x square. It's a positive, so the shape is smiley. The second one is the Y-intercept. And for Y-intercept, you can either just read it off and say, well, there's the Y-intercept. Or if you can't see that, you can just simply make x equal to 0. Substitute x with 0. So that gives me 0 minus 8. So that's minus 8. That's my Y-intercept. Now the X-intercepts, we said yesterday, make Y equal to 0 and factorize. Now x squared minus 2x minus 8, if I factorize that, I get x minus 4, x plus 2. So that means x equals positive 4 or x equals negative 2. And then my fourth one is now I must calculate the new turning point because the turning point is not the same as my y-intercept anymore. So I take my equation, remember, there's A is 1, there's B, and there's C. Now I need the equation x equals negative B over 2 times A. So what is B? We see there B is negative 2. So it's negative 2 over 2 times, and from my equation I get A is equal to 1. So that gives me 2 divided by 2 is 1. That's the x coordinate of the turning point. But I still want the y coordinate of the turning point. So how do I get the y? I just substitute this x equals 1 into my given equation, x squared minus 2x minus 8. So in the place of x, I put 1. So it's x squared minus 2 times x is 1 minus 8. So I take my given equation and I just substitute the x with the x that I calculated here. So that will give me 1 minus 2 minus 8, which will give me an answer of minus 9. So my turning point is the point x equals 1, y equals minus 9. And now I have everything that I need to be able to draw the graph. So if I draw now, shape is smiley, so I must make sure that I fit a smiley face into my points. Y-intercept, okay, let's see. Y-intercept -8. X-intercepts 4 and -2. Now, can you see that I don't take my axis and I take my ruler and I write 1, 2, 3, 4, 5, -1, -2, -3, -8. I estimate, but I estimate realistically, eh? And my turning point is 1 and -9. So 1 and -9 is more or less there. 1 and -9. Can I draw a smiley parabola through these points? Yes, I think I can. So there's my y-intercept. How will you get marks? You will get a mark for the y-intercept, but I must be able to see your answer there. So I must see that it's -8. I must see what's the coordinates of the turning point. I must see the x-intercepts, and then probably you will get one for the shape. So for a question like this, you can expect 1, 2, 3, 4, 5, 6 marks, more or less. Okay. Now, whether you calculate it here, doesn't matter. You must show it on the sketch. These are your critical points. The x-intercept, y-intercept, 2 coordinates of the turning point. Okay. So now there's my sketch. Can you see that the original graph moved from the y-axis, the turning point on the y-axis, it moved to the right. Okay, so now one question was, give the symmetry axis. So symmetry axis, where's the symmetry axis? The symmetry axis is through the x coordinate of the turning point. Can you see it goes through 1 on the x-axis? So what's the equation of this vertical line? It goes through the x-axis where? At 1. So we said in the previous slide, we said the symmetry axis has equation x equals the x value of the turning point. And there you can see that it works like that. So the symmetry axis is x equals 1. Okay, now they ask the domain and the range. Okay, now you know that there's arrows on the ends. So what's domain again? If you come from the left-hand side, where is the first x value that you will hit the graph? Well, this graph goes until to minus infinity and to positive infinity. So you can either say x element of minus infinity to infinity, like we said yesterday, or you can say x element of all the real numbers. And then domain, range. If I ask you the range, you remember range means y values. Where's if I come from the bottom, where will I find the smallest y value? There. The y value of the turning point. And can you remember yesterday we said the turning point is one of the points of your range. So it's from, there's the y coordinate, -9 up to positive infinity. Infinity is always a round bracket. What can you say about -9? Well, there's not an open dot there. The turning point is included. So block bracket -9 to infinity. Now, what they can also ask you, like we said yesterday, they can ask you, give the x values for which Now, can you see, now I can write fx because the graph, the name of this graph was fx. The x values for which fx is, now I want to ask increasing or decreasing. Which one will we choose? Let's choose increasing. Give the x values for which the graph is increasing. So what do? I come from the left-hand side with my little bicycle. And where will the graph increase? If I come from the left, the graph will first decrease up to the turning point, and then it will start increasing again. So where does it start increasing? Again, at the x value, the x coordinate of the turning point. And that is at 1. So it's for x element of, it's from 1 to infinity, because now it will just keep increasing. Now, must I include this turning point or not? Now you must just ask yourself, at that turning point, if you are there, are you going down or are you going up? You cannot say because you're 100% in the middle. So you are not increasing or decreasing, you are turning. So at that point, you are stationary, horizontal for a second. So you decrease, stand still so that you can turn and increase again. So therefore, you do not include the turning point when they ask you about increasing or decreasing. You exclude the turning point because at the turning point, you're not increasing or decreasing. You're just turning so that you can start increasing. Okay. Okay, let's draw another one. Now I've called this one gx. Gx equals minus x squared minus 4x. So my steps, shape. Now can you see that there's a negative 1 there? There's a negative 1 there. So it's a negative a, so the shape will be sad. Now I want the y-intercept. For y-intercept, make all the x's 0. So y equals minus 0 squared minus 4 times 0. That gives me an answer of 0. Now I want x-intercepts. Remember, that's the critical point. So for x-intercepts, make y0 and factorize. Now, people, don't forget the easiest factorization that you started with in grade 9. Factorization starts with, look for a common factor. And can you see there's an x and there's an x? So I'm going to take out, doesn't matter if you take out a positive x or a negative x, you will get the correct answers. Now, there's a minus x squared minus 4x. I'm somehow going to take out the minus x. Then what's left? Then there's a positive x left, and there's a positive 4 left. Remember, if you multiply back, you must get what you had. That's how you can test if you're correct. Now remember, this factor is equal to 0, or that factor is equal to 0. So do you agree with me that x is 0 or x equals negative 4? Okay, then I must still do the turning point. And now I must use the formula. X equals minus b over 2a. So b, can you see there's the a and there's the b. So there's the a and there's the b. So b is negative 4. So it's minus 4 over 2 times. And my a value is negative 1. So that gives me 4 divided by minus 2 is minus 2. How do I get the y coordinate? I substitute in my original equation, which is minus x squared minus 4x, minus x is minus 2 square minus 4 times x is minus 2. Now remember, I think I said it before, powers are more powerful than anything else. You must first do the square before you can times. So if you square, minus 2 times minus 2 is positive 4. And then you can times it with a minus. You remember, a square is always positive. And then minus 4 times minus 2 is plus 8. So that gives me an answer of 4. So my turning point is the point negative 2 and positive 4. Now I have enough information that I can draw. So there's my set of axes. Y-intercept is 0. Okay. X-intercepts, oh yes, there must be an X-intercept of 0 as well. So 0 and negative 4. Turning point, negative 2 and 4. So negative 2 is there in the middle. Negative 2 and 4. And we said it must be a sad parabola, yes. And there's your sad parabola. Where's the symmetry axis? The symmetry axis is in the middle of the two X-intercepts, or at the X value of the turning point, which will be negative 2. The domain, there's arrows on the ends. It's going out forever. So it's all the real numbers. And the range, remember, you come from the bottom, from the lowest Y value. But can you see it goes down forever? So the Y values go to minus infinity. So it starts at minus infinity and it will stop where? The highest Y value where you exit the graph is the Y value of the turning point, which is 4, and that point is included. Now I want you to see something. I will show you now with the previous one as well. Can you see that the X value of the turning point is exactly in the middle of the two X-intercepts? How do you get middle, mean? Can you remember? If you add those two X-intercepts, minus 4 plus 0, and you divide by 2, then you get most the average, the middle, the midpoint. So what's minus 4 divided by 2? It's minus 2, and look there. So your turning point is 100% exactly in the middle of the two X-intercepts. If you look at the previous one, it will also work like that. Look there. Your one X-intercept was minus 2, and the other one was 4. What's exactly in the middle of minus 2 and 4? Minus 2 and 4. Minus 2 plus 4 divided by 2 gives me 2 divided by 2 is 1. And look there. Can you see the X value of the turning point is the middle, in the midpoint of the two X-intercepts, which will also be the symmetry axis. So if you don't get the turning point with your formula that it's exactly in the middle, then you must know there's a mistake, and then you must go and find your mistake. Okay, let's ask for this one. For which values of X is, now this graph I named GX. Let's take increasing again, because now I have a sad parabola. So if I come from the left, I want to know where's this graph increasing. Now, can you see that from the left side, if you hit the graph, you go up before you turn and then you go down. So increasing will be to the left part of the parabola. And where's that? It's for all the x's smaller than -2. So it will be from minus infinity up to the x value of the turning point in this case, which is -2, -2. Now, if they ask increasing, decreasing, do you include the turning point? No, you don't, because at the turning point, you are turning. You're not increasing or decreasing, you are turning. You're stable for a second. Okay. Okay. Now, that was the first equation. If I can show you again, the first equation was y equals ax squared plus bx plus c. And the only thing that we had was actually the y-intercept. The x-intercept you had to calculate, the turning point you had to calculate. Now there's another form of the parabola. And that form looks like this. Y equals a x minus b in brackets squared plus q. Okay. Y equals a x minus b squared plus q. And I warn you again, these formulas are not on the formula sheet, so you must please know them. Now, what does that stand for? Okay, you know by now that A is give us the shape, smiley for a positive A, sad for a negative A. Okay, but now, what does this X and this P and Q stand for? This Q, P, and Q gives me the turning point. So if you see this formula, or this form of the equation, you are very glad because what is given here? The turning point is given. So you're very glad because you do not have to calculate the turning point. But now I want to warn you. Can you see there's a minus? Now, if there's a minus, then there's a plus. But the Q value stays what it is there. If there's a plus, then there's a plus. If there's a minus, then there's a minus. Now, I teach my learners, now this is really just a joke, but it helps you to remember. Now, I tell my learners, listen, the X's are like the men, the X factor, always otherwise. The Y's are like the women. What you see is what you get. Now remember, this is a joke, please. Okay. But that will help you to remember that if you subtract from the X factor, like the men always otherwise, then you must take a plus value there. And the Y, this Q gives you the Y value of the turning point. It's like the women, what you see is what you get. So if there's a plus, then there's a plus as well. So you can just read off your turning point. You do not have to go and calculate that. And then the X and the Y, what does the X and the Y stand for? It's still the coordinates of any point on the parabola, like we said yesterday. Okay. Now, before I draw number 3 and number 4, can you remember, let me just take it out of the way for a little bit. Can you remember the easiest graph that you started with, the first graph that you started with in grade 10? It was the graph y equals x squared and y equals minus x squared. Can you remember what the equations, what the graphs looked like? Y equals x squared was a parabola that there's a plus, so it was a smiley parabola smiley parabola, and it turned on the origin. And y equals minus x squared, there's a minus, so it's the sad one. So it was the parabola that was sad, but turned on the origin, at the origin. So your turning point was the origin. Now, if you think of that, and now I ask you draw y equals x plus 2 squared. Do you agree with me that I can add a 0 there? I can add a 0 there. Did I change anything? No, I didn't. Can you tell me something about this form? Isn't it the same as what I have there? Y equals a x minus b squared plus q. Isn't it that form? So can you see that the turning point will be, now I said -2 and 0. Now remember what I said. If you have a plus there, then there you must have a minus. Now, like the men always otherwise, the X factor. So what happened? If you have a plus there, the mother graph, that one, just moved 2 units to the left. 2 units to the left. So there's the turning point, -2 and 0. And it's a smiley parabola, so it will look like this. And all that you have to calculate is the y-intercept. For y-intercept, make x 0. Then you have y equals 2 squared, and that is a 4. And if I do number 4, can you see that again I have the same shape, the same form as what I have here. Y equals a x minus b squared plus q. So can you see, now remember, like the men always otherwise, the x factor, if I subtract from the 2, my turning point is +2 and the y value is 0. So it's this mother graph that just moved to the right. And all that I have to calculate is the y-intercept. And again, if I make that x 0 minus 2 squared is a 4 again. So what I want you to see, because this year in grade 11, you're going to move all your graphs, you're going to shift them sideways. Parabola, hyperbola, exponential graph, you're moving them sideways. And what happens if you move sideways? You add or subtract to the x. Now, can you see here? If you add to the x, the graph moved to the left. If you add to the x, the graph moves to the left. And if you subtract it from the x, can you see that the mother graph moved to the right? So if you subtract from the x, your graph moves to the right. Now, if you can just remember that, people, then you have learned a lot. Okay. So let's draw some more. Draw y equals x minus 2 in brackets squared minus 4. Can you see it's a parabola? Can you see it's the form where they've given you the turning point? Now remember, if there's a minus, if I subtract from the x, I must put a +2 there. And whatever that sign is my y coordinate of the turning point. Okay, but I must still follow all my steps. So the shape, there's a 1 in front of the bracket. It's a positive, so the shape is still smiley. Now I have to calculate the y-intercept. I don't have it, so I must calculate it. But how do I calculate y-intercept? I make x0 and I simplify. So that's a minus 2 squared is a 4. 4 minus 4 is 0. Okay, I must calculate the x-intercept. Now for x-intercept, make y0. But now, unfortunately, you have to simplify there. So you have to expand. X minus 2 times x minus 2, x minus 2 times x minus 2 minus 4. So that will give me x squared minus 2x is minus 4x, and then a plus 4 minus 4, which will give me x squared minus 4x, because the 4 and the minus 4 will cancel. Take out the common factor again in this case. This factor is 0, or this factor is 0, so x equals 0 or x equals 4. Do I have to calculate the turning point? No, I don't have to. I can just read it off. 2 and negative 4, as we've written there above. Okay, so now I have everything that I can draw. So my y-intercept is 0. So there's a 0. X-intercept 0 and 4. Yes, it looks right. 0 and 4. Turning point 2 and negative 4. Now, can you remember we said now, the x value of the turning point is in the middle, 100% in the middle of the two x-intercepts. Is 2 in the middle of 0 and 4? Yes, it is. So it's 2 and negative 4. 2 and negative 4. We said it's a sad parabola. 2 and negative 4. And can I draw now? Yes, I can draw. And there's my parabola. Okay, now you can do the domain, range, symmetry, axis, increasing, decreasing, everything. But I first want to carry on for a little while, and then we will do that again. Okay. Okay, there's another one with a minus. Can you recognize that it's the form ax minus p squared plus q? So can you see that they've given you the turning point? So that's all that you have to go and study. This is the formula of the parabola. It's the second formula. So I don't have to calculate the turning point. It's given there. Remember, if there's a minus, I must take a plus. But the y I just take as it is. So that will be my turning point. So the turning point formula was used in this case. Okay, shape. The shape, there's a minus in front of the brackets. So the shape will be sad. Y-intercept, I must calculate by making x0. So that gives me a positive 1 here. Minus 1 square is a positive 1 times negative is a negative 1 plus 9, which gives me an 8. Now I want the x-intercepts, so I must make y0. Now there is another method that you can also use, but I'm going to stick to this one. Expand, remember, 2 terms squared gives me a 3 term. So it's x squared minus 1x is minus 2x, minus 1 times minus 1 is plus 1, plus 9. Remember to multiply that minus in, so it's minus x squared plus 2x minus 1 plus 9. So that will give me minus x squared plus 2x plus 8. Now I must factorize, but because there's a 0, I can divide that minus away because I don't like to factorize with a minus in front of the x squared. So divide by minus all right through. So it's x squared minus 2x minus 8. So now I can factorize x minus 4x plus 2. So x equals positive 4 or x equals negative 2. And we said our turning point is 1 and 9. Turning point was 1 and 9. Okay, let's see if we can draw. It's a sad parabola. Y-intercept is 8. X-intercepts, we calculated 4 and negative 2. 4 and negative 2. Turning point 1 and 9. Now, is 1 in the middle of minus 2 and 4? Minus 2 plus 4 is 2. 2 divided by 2 is 1. Yes, so it makes sense. 1 and 9. And I draw my parabola. I have the x-intercept, I have the y-intercept, I have the turning point, and everything is fine. Okay. Good. Now there's a third equation as well. Now why is this important? Because tomorrow if I'm giving you the sketches and I'm asking you the equations, then it's important that you know the 3 different formulas. So you have to know the first equation, the second equation, as well as the third type of equation. Now here you see y equals a, x minus x1 in brackets, x minus x2 in brackets. Now if I can go back to the previous one, can you see what you have here? Y equals x minus 4, x plus 2. What does that give you? It gives you the x-intercepts. What did we do with the previous one? Where was it? There. What do you have here? X minus 4, x plus 2. What does it give you? It gives you the x-intercept. So can you start seeing something here? Can you see that this x1 and x2 stands for the x-intercepts? It's the x-intercepts that were given. But now again, be careful. If there's a minus, the x-intercepts are positive x1. So it's like x minus x1 equals 0. So x equals positive x1 and x equals positive x2. So if there's minuses there, there must be positives there. X factor, like the men always otherwise, x factor, if you subtract from an x, there must be a plus. If there's a minus, there must be a plus, or if there's a plus, then there must be a minus. We'll do an example just now. Okay. A still gives me the shape, smiley for plus or sad for minus. And these x's, those two x's and the y are still the coordinates of any point on the graph. Okay, so the third equation is the one where the x-intercepts are given. Now, I say again, you will see tomorrow when we have the sketches, it's important that you can see, okay, I have the turning point, so therefore I'm going to use the second type of equation. Or, no, they've given me the x-intercepts, So I'm going to start with this equation. That's why it's important that you must know them. Okay, now let's see. They ask draw. So there's my A. So the shape A is positive. So it's a smiley parabola. Y-intercept. Now the y-intercept are not given. You have to calculate that. So how do you calculate y-intercept? You make the x's 0. So that's 2 times negative 1 times positive 3, which will give you a minus 6. Then you want the x-intercepts. But do you have to calculate them? No, because this shape gives you the x-intercepts. But now remember, it's x minus 1 equals 0, so x equals positive 1. Can you see? If there's a minus, then there's a plus. Or x plus 3 equals 0, so that means x equals negative 3. If there's a plus, then there's a minus. Okay, now I need the turning point. So I'm going to multiply out first. So if I FOIL, then I'm going to get x squared minus 1x plus 3x is plus 2x minus 1 times positive 3 is negative 3 minus 3. And now I times in the 2, so that will give me 2x squared plus 4x minus 6. And by the way, can you see that the y-intercept was minus 6? And yeah, this minus 6 confirms that. So I know that I'm on the right track. So what's the formula that I must use? X equals minus b over 2a. So there's my a, there's the b value. So it is negative, b is 4, divide by 2 times, a is 2. So that gives me minus 4 divided by positive 4 is a negative 1. But now I still need the y coordinate. Now you can either substitute it in this equation, or you can substitute it into the original equation. It really does not matter as long as you work correctly. It does not matter. So say I take this equation, 2, then I substitute x with minus 1, substitute x with minus 1. That will give me a 1 times 2 is 2. 4 times minus 1 is minus 4. Minus 6, that's minus 10 plus 2 is 8. So my turning point is minus 1 and 8. No, minus 1, minus 8, sorry, minus 8. Minus 10 plus 2 is minus 8. Can you see that I confirm all the time with my shape? When I looked at the shape and I realized, oh, that's going to be trouble, I went back and I searched for my mistake. So it does not matter if you make mistakes. But as long as you can see it's a mistake, then you can fix it and you will not lose any marks. Okay, so y-intercept minus 6. X-intercept, we said 1 and negative 3. Turning point was minus 1 and minus 8. Is minus 1 in the middle of minus 3 and 1? What's minus 3 plus 1? It's minus 2. Divide by 2 is minus 1. Yes, so it's correct. Minus 1 and minus 8. If you want to, you can draw the symmetry axis there to just help you, to just guide you. So there's my critical points. And if I start drawing There's my parabola. Okay. Is it easy? Good. I think I have another one for you. So let's finish with this one. Draw y equals minus. So can you see immediately? It's a sad parabola because there's a negative. So definitely the shape is sad. And can you see what shape it is? This one, the form of the equation. You have the X-intercepts. Okay, so we must calculate the Y-intercept. To calculate Y-intercept, we make X0. If you calculate that, you get minus 5 times 1 is minus 5 times a negative will give me a positive 5. X-intercepts, oh, I don't have to calculate them because it was given here. But remember, if there's a minus, then I must take a plus. And if there's a plus, I must take the minus. So I don't have to calculate them, I have them. And then my turning point, I have to multiply. So if I FOIL here, I get x squared minus 5x plus 1x is minus 4x. Minus 5 times plus 1 is minus 5. If I multiply in, I get minus x squared plus 4x plus 5. And I want the turning point. So x equals negative b over 2a will give me minus 4 over 2 times. And can you see my a value is minus 1? So that will give me a minus 4 divided by minus 2 is positive 2. And to get the y coordinate, I substitute back. Now I say it doesn't matter if I use this one or if I use this one. Now just to show you that it's going to work, I'm going to use this one for now. So minus, in the place of x, I put a 2. 2 minus 5, 2 plus 1. And now I'm going to simplify. That gives me a minus 3. 2 plus 1 is 3. If I multiply, I get 3 times 3 is 9. But it's minus 9 times another negative. So that will give me a positive 9. So my turning point is 2 and 9. Let's draw. So my y-intercept is 5. 5 there. X-intercepts, we said 5 and negative 1. Can you see I must plot them more or less in the correct places. Otherwise, I'm going to have a skew graph. And then my turning point 2 and 9. 2 and 9, can you see it fits this sad parabola shape. So 2 and 9. Now is 2 in the middle of minus 1 and 5? 5 minus 1 is 4. 4 divided by 2 is 2. So yes, 2 and 9. And there's my sad parabola. If they ask me for the symmetry axis, can you see there's the symmetry axis? What's the equation of the symmetry axis? X equals wherever the turning point X value is, X equals 2. If they ask me the domain, you remember, you know by now that domain is always X element of R because the parabola is going out and out. And the range, you know that it's Y values. Can you see the parabola is going to minus infinity? So it starts the smallest value. Remember, always the smallest value first. Minus infinity up to, what's the highest value? It's the y value of the turning point, which in this case is a 9. And you can, well, not you can, you must include the turning point. And say I ask you now, say I ask you for which values of x is the graph. Now we did increasing the previous 2 times. Let's take decreasing now. What does decreasing mean? It goes down. So if you come with your bicycle, if you hit your graph from the left-hand side, it goes up first. Then it turns at the turning point and then it goes down. So where's the x values for which it's decreasing? Can you see? It's from that x value. So it will be from this x value to the right-hand side. So it will be from 2 to infinity, because now it's just keep to decreasing all the time. And remember what we said? Decreasing or increasing, you cannot include the turning point because it's turning there. So you will put a round bracket there. Okay. Functions, graphs are really very, very important. They're really going to ask you that in grade 12 as well. All the stuff that I've taught you now. So tomorrow I'm going to give you sketches and then we will have to find the equations. So see you tomorrow again, same place, same time. And then you must please, well,